Welcome to the video tutorial that will give us some extra practice on percent mass volume calculations. So percent mass volume is one of the different ways that we communicate solute concentrations. So there is an introductory video tutorial that goes over solution concentrations that it would be a good idea for you to view before viewing this tutorial. So remember that percent mass over volume will be symbolized percent m over v, but not everybody uses mass. Some people describe it as weight. And so don't be confused between the mass or the weight. Either one is the same information is being communicated. Now, in using percent mass over volume, for example, if we're told that we have X percent mass over volume, then when we interpret this, the X tells us that we have X grams of the solute per, and then the volume will be in milliliters, and because of the percent, that means we would have 100 milliliters. So that is how we read the concentration units. So let's practice calculating percent mass volumes. If we have 100 milliliters of a blood serum containing 5 milligrams of thyroxine, a hormone released by the thyroid gland, what is the concentration in percent mass over volume? So here we're going to calculate the percent mass volume. So this is done in the traditional way we calculate percents. The main thing here is watching the units. We need to have the solute in grams, the volume of solution in milliliters, and then we're going to multiply by 100. So for this example, the mass of our solute is 5 milligrams of the thyroxine. So we'll just give that an uppercase T. And then we have 100 milliliters of solution. And so we're going to need to do a unit conversion here because the mass of our solute is in milligrams, not grams. We don't have to do anything with the volume since it's already in milliliters. So now we'll do a unit conversion that there are 1,000 milligrams in 1 gram. There's also a video tutorial that talks about unit conversions. So if this step is causing you some trouble, please take advantage of that resource. And then because it's going to be a percent, so now we have our mass in grams and our volume in milliliters, and then because we're doing a percent, we multiply by 100. So if we punch this through our calculator, we would, oh crap, excuse me, we would see that it's 0.005% thyroxine, and that would be, to make that, right, that would be mass over volume of thyroxine. So there would be our result. Let's practice that one more time. So potassium iodide, when we hear that name, we instantly think of the chemical formula, is used to treat iodine deficiencies. What is the percent weight over volume? Remember, that's the same as mass over volume of a 75 ml solution containing 2 grams of potassium iodide. So remember that we want it to be grams over milliliters times 100. So here's our mass. We can tell by the mass units of gram, 2.0 grams potassium iodide, 75 milliliters of the solution, and because we're asked to do a percent, we'll multiply by 100. And then we punch this result into our calculator, or these values. And we would see that it would be, our calculator tells us 2.6667% weight over volume. And then for sig figs, let's see here, we should have 2 sig figs, so 2.7% weight over volume. And now that I've mentioned sig figs for this calculation, some of you may have noticed up above that I ignored the sig figs here. So 2 sig figs and 3 sig figs. So I made an error in reporting this answer. I should have added a trailing 0 so that we correctly reported to 2 sig figs, our final answer. Alrighty. Now, so calculating the percent mass volume of a solution is an important calculation that you want to be able to do. But sometimes we'll do calculations where we're given the percent mass volume and we have to use it as a conversion. So let's try that. Okay, so here we have examples where we're given the percent mass volume and we need to use that in a calculation. For example, how many grams of sodium chloride, all right, so this is what we're trying to calculate, are needed to make 750 milliliters, there's a volume, of, here's our concentration, 0.95% weight over volume. So the key here is to make sure that we understand how to use this concentration information. So this is telling us that there's 0.95 grams of our solute, sodium chloride, in every 100 milliliters of the solution. So this is the key piece that's going to help us solve this question. So we want 750 mils of the solution. So this is where we're going to start. We'll start here. So this is the solution we want to prepare. And the concentration that we want to prepare is 0.95 grams per 100 mils. So we let the units guide us. We have milliliters of solution on the top. So we're going to use this conversion directly as we've written it. Know that we can always flip them if needed. Especially when we're working with concentrations, right? It's an important bridge from solution to solute. So not only do we have to write the magnitude of the number, its units, but what exactly are we talking about? And that gives us the ability then to cancel this. So now we're in grams of sodium chloride. We're done. Now we'll take the time to punch the data into our calculator. And we get a final result. We would need to weigh out 7.125 grams. And of course, we'll pay attention to sig figs. So in this example, we have 2 sig figs here because there's no decimal. And here we have 2 sig figs as well. So we would round our answer to 7.1 grams sodium chloride. Alrighty, let's try one more of these to help you feel comfortable before you start working on your homework. How many grams of glucose are needed to make 500 mils of a 5.5% mass over volume solution? So for glucose, we'll just give it an uppercase G, right? And how many grams? So it's very similar to the previous question. All right, this is the volume of solution that we want to make. And then here, right, so take the time right now to write out what this concentration is telling us. This is the key piece. right? So this concentration is telling us that we have 5.5 grams of glucose in every 100 milliliters of solution, right? So I just wrote it differently from up above. These are two ways to write the same thing, whichever way is more comfortable for you, right? I guess we'll just do it here for completion. Okay, so that's the key. That's the key piece. Now we can solve the problem. We want to prepare 500 milliliters of the solution, and this concentration value is what allows us to convert from the solution to the solute, the glucose that we're interested in administering. And in this case, oh, we're done, right? We have the milliliters of solution cancels, and we're left with grams of glucose. So the units tell us that we've set the problem up correctly, so now we can take the time to enter the data into our calculator, and we find that we would need to weigh out 27.5 grams of glucose. And if we look at our data, there is a decimal here, so that's 3 sig figs for those trailing zeros. Here we're at 2 sig figs, so we'll report our answer to 2 sig figs. With a 5 we round up, so we would need to measure out 28 grams of glucose. Alrighty, so there's a couple practice problems to help you feel more comfortable working with percent mass over volume concentration units, and this would be a good time to work on a few homework questions to reinforce your understanding.